Hello everyone, this is Cody Jackson for Cody, and we are continuing our journey into object-oriented programming in Python. This is part 2, and this time we are going to talk about modules, inheritance, and operator overloading. Again, you've seen this before, you'll see it in the future. If you want to follow along at home with more explanation than what I'm putting in the video, these are the books to use. I wrote the Learn Programming in Python book, primarily for beginners. Secret Recipes of the Python Ninja is a little bit more advanced and a little bit more step-by-step in how to do certain things. Yeah, so there it is. We're going to talk about modules. So, modules, we've talked about before, are basically individual files, Python files, that allow you to import either the entire file or parts of the file, classes, methods, functions, into your particular project that you're working on. So, because you can import classes directly, this allows you to import only those parts that you need for your project. You don't need to import an entire class into memory if you only need a specific class. To my understanding, some languages like Java are different from that in that you have to import everything in there even if you only need one specific part of it. Because I know in the past I've talked to some programmers who complained about their resources being used up by importing these modules that were basically taking up all the space that was available to them, and they didn't need all of that stuff. If you're going to import just a specific part of a module, then you just use from that module name import X, whether X is a class, a method, or whatever the case may be. You do have the option to use from module import star, which imports everything in that module into your current namespace. But when we talked about variable shadowing, importing into your current namespace is bad, because at that point Python doesn't know if you're talking about your current code or the inherited code, and it's going to start generating errors and warnings because it doesn't know what you're talking about if you have variable shadowing. So when you're importing into a local environment, you're only going to be able to import classes, methods, and functions from that external module. Therefore, as a best practice, make sure that you're putting all of your code, as much as possible, within a class, method, or function if you plan on using it later on. If you don't have any of those namespace objects, the best you can do is copy the entire file over as a import object. And so you're basically stuck with not quite spaghetti code, but you don't have the modularity of using modules. You're basically importing an entire file into your namespace so you can work with it, whereas being able to import a single class gives you a lot more functionality because you have a reduced overhead, and you can clarify exactly what parts of a file you want to work with. Inheritance. So, why do we want to use inheritance? We touched on this briefly in the previous video, but inheritance allows you to greatly improve the efficiency of your code writing by inheriting methods, parameters, properties that are already in existence from that parent class. And therefore, you don't have to rewrite those again. They're automatically inherited, so you can use them either as is, you can expand on them, you can delete or ignore them if you don't need them for that particular class. So there's a lot of functionality that comes with using inheritance. You do have the possibility of using multiple inheritance which allows you to basically take all of the methods and parameters from from different classes and roll them into a single class. Now, the problem with that is you can lose track of what's being inherited, especially if it's not your code. If you are doing multiple inheritance on someone else's code and they make changes to that underlying code, you may not recognize it and update your code accordingly. Then you get errors that you have to track down to figure out, is it my code? Is it the imported code? Stuff like that. Regardless of whether you're using single or multiple inheritance, having a generic parent class allows you to use the subclasses to specialize that generic class. And I believe we talked about this last time when we were talking about having a generic vehicle that can be something that goes on land, water, or air. And then you have specific subclasses that will create those specific instances of a car, a plane, a boat, and so on. For those following along at home with the book, here is an added bonus. On page 104 of the book, the publisher put in the wrong screenshot. Now, if you have a later version, hopefully they fixed it. I told them about this, but this is what should be on page 104 regarding class inheritance. Because it's here, I'm not going to type it out. We'll just talk about it as is. So let me get my little pointer. So, we're defining a parent class, and we just call it parent. And we set two methods for it. One is set data, and the other is display. You might have seen this before. This is very similar to what we were doing with making our knights from the previous video. So one, we are setting the data equal to the value argument, and then the display just prints that value that we put into the data. Our child class inherits from parent and overrides the display method by saying my value is whatever that data value is. But we are inheriting the set data method, so we don't have to redefine that again. It's already there. It's already available to us. We don't have to do anything for it. So we define X and Y as two different instances. One is a parent, one is a child. We can use the set data method for X to take a string, the boy called Brian. Y we use to set Camelot as the data value. When we call X display, we see that it returns the boy called Brian. And when we do Y display, rather than just printing the data itself, which would in this case be Camelot, it goes ahead and it takes the new method defined for child, which says my value is Camelot in this case. So I hope that makes sense. Basically, we have a parent class, we have a child class, or superclass, subclass. They're both equally common. The child class inherits everything that the parent has, and the only thing that we're doing is overriding the display method to change how that data that is being set is displayed. Alright, so now we move on to operator overloading. So operators are like your plus sign, multiplication sign, things like that. Through duck typing, which I believe we talked about last time, Python is able to interpret what you want to do. So if you have a plus sign with numbers, then it will add those numbers together. But if you have strings, then it will concatenate those strings together. Operator overloading allows you to use the built-in functionality that Python provides, and you can make new ways of using these operators. So the example of plus being used for numbers or strings is an example of operator overloading. You can use the exact same operator and it will do different things depending on what the context is of that use. Now, I used the plus sign as an example, but because pretty much everything in Python is an object, operator overloading doesn't just have to apply to plus, times, things like that. It can really apply to just about any sort of object that has an action available to it, and that action is being the operation. So things such as addition, slicing, printing, things like that can all be overloaded for whatever you need to do. So even though these actions or the operations are handled as class methods, through overloading you are able to tie the desired behavior closer to Python's model of objects and how those object interfaces are used in Python's built-in objects. So you basically get more consistent use of those object interfaces, which basically means that you have easier functionality and easier to learn when it comes to overloading. So if you wanted to overload a particular function, or operation I should say, by creating a custom user class, then you want to look for the dundered methods within Python. Dundered basically means double underscores, dundered, double underscore, at the beginning and the end. So I put some examples up here. Add and mul are examples of built-in dundered methods that Python uses for multiple things. Through duck typing, the functionality of a method, a dundered method, will be determined based off of the data types. If it's locally defined, then it will use your locally defined method first, but you still have access to the built-in functionality. Alright, so we went ahead and made a parent, child, and grandchild to show inheritance as well as operator overloading. And in case you see this and you feel like commenting on it, yes, I know I spelled display wrong, but it doesn't matter because we never actually touch it. We're only dealing technically between the child and the grandchild, because the child inherits, or sorry, the grandchild inherits from the child. So the only method we really care about here is the display method, and then the set data that's inherited from the parent. Regardless, in our grandchild class, we define the initialization method to accept a value and set that value to data. We overload the addition method that's built in, dundered, by returning a grandchild's self data and the new value that's applied. And we overload the multiplication dundered method by adding a new value and basically returning the data that we already have and a new value. So we go through, we create a grandchild instance, we provide it with a immediate initialization object of spam as a string, and you can see that it works just like it did with the child, where my value is spam, what was provided. Now, if we do b equals a plus eggs and display that, we see my value is spam eggs. We already said a up here was spam, so we are concatenating two strings together. If we do a star 3, so a multiplied by 3, then we get my value is spam, spam, spam. So same thing that a string multiplication does, We are just overriding it to immediately take our data out, which is our display value of my value is, and adding the string multiplication functionality of Python. So basically this portion here is built into Python, as is this portion, but we are overloading those inherent values to provide a little bit more in terms of the output by already taking the child's display method of my value is data and then adding in that built-in functionality. So we're not doing a whole lot here. It may seem like it when you look at the code, but in reality all we're doing is saying take the inherited display method from child, my value is data, and then append whatever Python would normally do with those values to that. And that's why we have our output as it is here. I can't say that I have ever overrode methods. I do use initialization. I have used representation for what a string output of a class should be, but that's not necessarily overloading. That's basically using those methods as designed. Redefining what add should do is an example of overloading, and I have not done that. But there are cases for it, especially depending on custom code projects. You may need to add some additional functionality that basically streamlines how your code will work. So for example, with our addition here, just basically concatenating a string together wasn't good enough for us, and so we wanted to make sure that when we added it, we always have my value is whatever that concatenation is. Oh, and I should also mention that those two overridden methods only exist when we're within the grandchild class. If we tried to do that with the child or the parent class or anything else, we would get an error, most likely along the lines of an attribute error telling us that there's no type in existence because we are not using the correct class that has defined those methods. So we're at the end of this video. In conclusion, we talked about module functionality and importing and how to do it correctly. Why class inheritance is useful. We looked at an example of inheritance. We talked about operator overloading, looked at an example of it, and basically just mentioned that for beginners, it's not something that you're going to worry about. And even in advanced code projects, I very rarely see it, except in very special cases. So don't get locked up in operator overloading. There's a very good chance you'll never have to deal with it. So that's it for this video. Next time, we're going to talk a little bit more about object-oriented programming. Specifically, we're going to talk about properties and specific methods that are available to pretty much any object, and those are class and static methods. Everything we've been talking about so far are instant methods. So we'll talk about how to make a method that can apply to any object of a class, as well as static methods, which can basically apply to almost anything. That's it for this video. I hope you enjoyed it. I hope you found it interesting, or at least educational. If you have any comments, questions, concerns, again, let us know in the YouTube comments. Until next time, have fun, keep learning. Thanks.